This week we're going to start looking at ways that you can QC your data and handle missing data in Python. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to start a short series on how you can deal with missing data in Python. And this is actually a really complex and important topic because if you don't deal with missing data correctly, you can get incorrect results, bad statistics, and that can give you bad interpretations of your data that you might even publish. Or it could just crash a really long-running calculation when missing data are encountered. So we're going to use some data from the Iowa Environmental Mesonet Archive. It's ASOS readings from the Boulder Station BDU. And I was able to get data all the way back to 2010. Let's say we're doing some kind of climatology study. So this week we're going to talk about the first step in dealing with missing data, which is to QC the data. So when the data comes in, we need to take a look at it, see what we can learn about it. What are some characteristics of it? What's the min? What's the max? What's the spread? Is there missing data placeholders anywhere? What can we discern with just a cursory look through the data? And that also helps us figure out what might be interesting to investigate. So to start with, I'm going to import pandas as PD. We're going to use that to read this data. And we currently get a warning about the next release of pandas requiring PyArrow. We're going to use the read CSV method on our file, bdu.csv. And first, let's just read it in and see what happens. We get a warning that several columns have mixed types, so that should immediately make us wonder what's going on there. And if we look at the head of the data frame, we can see, one, there are quite a few columns here, 30 columns of data, in fact. And some of it we're not going to want for this climatology. Maybe I'm mainly interested in temperature, dew point, and wind climatology. So we're probably not going to need the weather codes. And I see a lot of M's, which probably stands for missing. So that's something to note immediately. And that's probably what's causing this mixed data types, because we have numeric data mixed with M's for where data are missing. Maybe a sensor was broken. Okay, so the first thing I'm going to do is I'm going to reduce the amount of data that I'm reading in. Using use calls, I'm going to read column 1, 2, 3, 4, 5, 6, and 8. And now I have my valid time, temperature, dew point, relative humidity, direction, speed, and altimeter setting. Okay, so the first thing I might want to know about this data is what are the ranges and what's the distribution look like? Pandas has this very handy describe method, but when I use describe on this data frame, I'm not getting something that's very handy. I'm not seeing any of the statistics I'm used to seeing. I see a count, which I expect, how many unique values are there, a top value, and how frequent that top value is seen. But I don't see anything like numeric mean, quartiles, and so on. Well, that's probably because we have missing data. So I'm going to copy my read statement from before, and I'm going to start out by saying, well, I know that my missing values were marked with M. I don't know if they're marked with anything else. Some data sets have multiple missing markers. But let's start with this. And now let's describe. Now I see something a little more useful. I see my mean, standard deviation, min, quartiles, and max. So I have the same number of data points for each, you would think, but we don't. Why is that? It's because we have missing data. So we're going to have to figure out how we want to deal with that. I have the mean. See, for temperature, it's 52 Fahrenheit, about 30 for the dew point. So those all look reasonable. I'm looking for things like, do I have relative humidities over 100% or below zero, for example? I have some pretty low relative humidities, 1.71, and my max is 100. Okay, the wind direction, do I have anything that's not between 0 and 360? Doesn't look like it. Wind speeds, everything's realistic. I don't see anything reporting winds exceeding the speed of sound or anything crazy. So these all look like reasonable data values, but we're just looking at summary statistics here. So one of the things that I could do would be to say, well, how many values are missing and what percentage of my data set is that? I mean, I know from the count roughly how many there are, but these are very large numbers of values and it's hard to get in my head. So I'm going to write a little loop for call in df.columns. I'm going to print the column name, and then I'm going to print how many missing values I have. So the length of df.index is how many rows are in that data table. I'm going to subtract the column, how many things are there. So we're not missing any valid times. That's good. Otherwise, that data is totally useless. Missing about 1,700 temperatures and dew points. Those seem like they would be on the same sensor, so that's realistic, I think. Missing more relative humidities, which is interesting. Direction and speed, both in the 6,000 range, but not the same number. So that's interesting as well. And then we're missing almost 1,300 altimeter settings. That seems like a lot. But we're also dealing with a lot of data here. We're dealing with almost 14 years of data. So I'm going to add in what percentage of the data are missing. So we'll take that same number and divide it by the total number of rows in the data frame and multiply by 100. So we see at worst we're missing 1.7% of the data. Most of it's 0.5% or less though. Okay, so we get a little feel for that. But now maybe I want to know some more about the spread of my data, other than these statistics in a visual form. What rows are cross-correlated with each other? What show no correlation? Are there any obvious outliers? This is where a pair plot can be really good. So we're going to import Seaborn as SNS. And I'm going to call the pair plot function on my data frame. This will take a little bit to run. Pair plot plots everything in the data frame against everything else. And on the diagonal, where it would just be a one-to-one plotting, it shows the histogram for that variable. Okay, so our plot has rendered. And let's look at what we've got. So here's those histograms along the diagonal. That's a good place to start. Temperature, we've got relatively normal distribution, one little spike here that could be interesting. Dew point, sort of a bimodal distribution, another spike. Relative humidity, a very high proportion of 100% readings, it looks like. Direction, a lot of readings in a pure north direction, so we'll have to look at that and investigate. Wind speeds, there's a pretty high bar at 0. And then altimeter settings, a relatively normal distribution with kind of a long tail here. What about on the cross plots? Looking here, we've got temperature against dew point, and we see a pretty clear one-to-one line, where for a given dew point, say a dew point of 25, we have temperatures that are 25 and above, which makes sense. Let's see, what other interesting relationships do we see? Temperature and what's this? Wind speed. So we can see that we have generally higher wind speeds and temperatures in that 40 to 70 range. Looking for any other correlations. Speed and direction. We see a pretty pronounced spike with the highest wind speeds being in a westerly wind. Okay, so there's a few interesting things we can investigate just from looking at that pair plot. But I want to start digging in from a QC perspective on what looks odd to me. The first thing that looks odd to me is in the wind direction. So let's make a histogram of that. I'm going to use the histplot function. And let's look at the wind directions. Yeah, so we have under 10,000 readings for most directions, but then we have over 100,000 readings, 10 times more, at a direction of 0. So that immediately catches my eye, as that's going to throw my statistics way off. And do I really expect that many north winds? Well, no, I don't. A 360-degree output is a north wind. 0 is for calm wind. So there were a lot of calm wind days. And we don't want to include that in our direction analysis. So we would need to take all of those wind directions of 0 and throw them out when we're doing statistics on direction. That's a great thing to know. And something that we might want to handle as missing data, because when there is no wind speed, there is no wind direction. So encoding it as 0 doesn't seem like a great way to handle that. Let's do the same thing when we look at the wind speed. Let's verify that hypothesis, other than we can read some documentation. And we see, yeah, there are over 100,000 0-knot wind readings, over 100,000 directions of 0. So that is definitely what's going on. Those are our calm winds. And then we see a logarithmic or power law wind speed distribution here. Okay, so just by doing some simple plotting, some pair plots and some histograms, we've already learned a decent amount about this data. We've handled some of the missing values by using the M marker, but we now know that there's more that we need to do to this data before we can put it into a machine learning method or do anything else with it. I hope that you found this useful, and we'll keep talking about how to work with missing data on the next MetPy Monday.